know someone serving in the military overseas? One way you can show your support is to send a care package to the troops. Care package is a great way to express your gratitude, and it will boost the morale of the person receiving it. Care packages can contain letters, pictures, books or magazines, and most importantly, snacks, because most of the time the troops are eating MREs. Ever heard of them? MRE stands for Meals Ready to Eat. MREs are used because they are lighter than canned foods, don't require a microwave or a refrigerator, have a shelf life of 3 years, and can withstand a parachute drop. MREs have been used in the military for years and provide servicemen and women with a hot meal in seconds. That's where the chemistry comes in. Think about it. If you're out in the middle of nowhere without a microwave or, electricity, how do you ever get a hot meal? Well, these MRE things can get mega hot. They heat about 12 ounces of food to 190 degrees Fahrenheit in minutes without a flame. That's crazy! I had to find out how these things work. Well, inside the packaging, a chemical reaction occurs. To get the food nice and hot, magnesium reacts with water in the presence of a catalyst. One of the products of the reaction is a lot of heat. Seriously, you don't want to touch this thing. Any chemical reaction that gives off heat or energy is called an exothermic reaction. When you hear the word exo, think out. Energy goes out. Kind of like when you hear the word exit. That means out too. Endothermic reactions absorb heat or energy. That's not hard to remember. Endothermic means heat goes into the reaction. Now this may be news to you, but all chemical reactions involve energy. It is stored in the chemical bonds of reactants and products. Energy is used to break bonds in the reactants and is released when new bonds form in the products. I really like exothermic reactions. Here's a diagram of what happens during an exo. What you really got to take in here is the y-axis of the diagram. Energy is increasing from bottom to top along this axis. So, during an exo, the energy released when new bonds form is greater than the energy used to break the bonds in the reactants. Check it out. You can see this downward slope is bigger than the upward energy investment. More energy goes out than in. Well, all that energy's got to go somewhere, so it leaves or exits into the surroundings as heat. The difference in energy between what the reactants and products is called enthalpy, or delta H. So anytime you see a triangle symbol or delta in chemistry, that means change. So delta H refers to the change in energy or heat. But we'll come back to that in a bit. So what's up with that crazy camel hump on our cool chart? That's the activation energy, duh, or the energy that is needed to get the reaction going. Looks like a roller coaster, doesn't it? Before a roller coaster can accelerate, it has to go up a big hill. Reactions have to go over an energy hill too before they can get going. Endothermic reactions are pretty cool too. Check out this diagram. A huge energy investment is needed to get over that steep hump. It takes more energy this time to break bonds than to make them. With endo reactions, energy must be absorbed from the surroundings for products to form. Big slope at the beginning and a little slope at the end mean that more energy goes into the reaction than comes out. All right, let's make a sweet chart to sum all this up. Exothermic reactions, like the magnesium-water reaction inside an MRE, release heat. Not as much energy is needed to break bonds, so extra energy is released as heat. More energy leaves the system than enters. The change in enthalpy, or delta H, is negative because heat is lost from the system. Energy is not really lost, it just moves or changes from one type to another. The law of conservation of energy states that energy can be converted from one form to another, but not created or destroyed. The total amount of energy in the system plus the surroundings is constant. This law is a lot like the law of conservation of mass. During a reaction, energy can change from potential energy stored in chemical bonds to kinetic energy absorbed or released as heat. The total amount of energy in the universe is constant, it just moves around a lot. Ever use one of these? It's an old school ice cream maker. Salt is added on top of ice to lower the temperature even further than using just ice by itself. Here we have an example of an endothermic reaction. Energy is absorbed when the salt dissolves in water. Bonds are broken, absorbing heat and cooling the surroundings. So your ice cream freezes faster. So endothermic reactions absorb heat and require a lot of energy to break bonds. More heat goes into the system than leaves the system, and this time delta H is positive because heat or energy moves in rather than out. Well, there you have it, endo and exo reactions. Until next time, this is Lisa D signing off.